Okay, so let's just jump right into this. When you're broadcasting a live event, think Formula One, a huge stadium concert, the final game,
Right.
you've got two things you absolutely cannot compromise on.
Yeah.
Perfect 4K or even 8K resolution and zero delay.
Zero delay.
Yeah,
Absolutely. And that's where standard copper cable just it falls apart. It can't handle that much data over the distances you need.
exactly. So our mission for this deep dive is to look at the really elegant solution that pros are using for this.
We're focusing on one piece of tech in particular. It's the Thor Broadcast F-12G-2SDI-CWDM kit. It's basically designed to solve that exact problem of distance and bandwidth all at once.
And the number that really defines its advantage is that transport time. 1 millisecond.
Mm.
I mean, to put that in perspective for you, that is completely, totally imperceptible. Your brain cannot register a delay that small.
It's the definition of plug-and-play reliability. You're sending two separate SDI video sources over just one single strand of fiber.
Okay, so speed is solved. But, speed is nothing if the signal quality isn't there or if it's not versatile. How does it handle all the different video formats we use?
That's the power of 12G SDI. The system is smart. It auto-detects everything from, old school SD-SDI like 480i
Wow, legacy stuff.
all the way up to the huge bandwidth of 12G SDI, which is what you need for 2160p at 60 frames per second. It simplifies everything.
So the real takeaway is that you're future-proofing the setup. It's not just about today's 4K. It's about being ready for 8K tomorrow, all while keeping the cabling simple. No more copper spaghetti monster.
And that integrity goes beyond just the video. The promise here is what they call transparent and lossless transmission.
So broadcast level.
Exactly, PRO DVB standards. And crucially, that applies to the embedded audio too, the AES-10 and MADI signals. If that audio sync slips even a tiny bit.
The whole broadcast is unusable, a
Right.
disaster. Now, this is where it gets really interesting for me, the physics of it. It uses single-mode fiber at a 1310 nanometer wavelength, and the default distance is a critical 10 kilometers.
Which brings up the big question, right? How do you make sure that signal is still perfect after traveling through 10 kilometers of glass? The answer is a feature called clock recovery.
A technical silver bullet. Okay, explain that. What is clock recovery actually doing inside that box?
Well, think of it like a digital metronome.
Okay.
As the data travels, the signal naturally gets what's called high-frequency jitter. It's just the data packets losing their perfect rhythm.
So the timing gets a little messy.
Precisely. So both the transmitter and the receiver have this clock recovery function. It looks at that incoming jitter and completely regenerates the data, locking it back onto the correct SMPTE rate, like the massive 11.88 gigabits per second for 12 GSDI with a pure, clean clock.
That is essential for professional video stability. It's amazing how much is going on inside a simple plug-and-play box.
It has to be. In these high-stakes environments, live sports, racing, 8K TV production, there's no room for error. They even added practical things like a hot shoe screw for mounting it on a camera, status lights.
And you get a local loop out on the transmitter and dual outputs on the receiver. So it really is a complete solution.
It is.
We started this talking about why copper just isn't possible. And we've shown why fiber is the answer.
Yep.
But let's end with the brutal physics of copper to really drive this home.
Let's do it. So consider this. Your standard BNC coax cable can push old SD-SDI, which is about 270 megabits per second, maybe 600 meters. That's fine.
Okay, that's a decent distance.
But once you jump up to the data rate you need for top-tier quality today, that 11.88 gigabits per second for 12G SDI, that same copper cable, its maximum distance drops to just 75 meters.
75 meters. Wow.
That's it.
That's a stunning drop. So that really shows you why if you're covering anything bigger than a small room, you have to trade copper for glass.
The modern broadcast world is built on light, not electrons.